Am I audible?
Yes, ma'am.
Okay. Who has joined right now? Just one. Okay. Wait only for a minute, and if anybody is joined, it's fine, or else I'll start with the content. Everything is visible. Am I audible clearly?
Yes, ma'am. Everything.
Purposely, I'll keep my video off because there is a network issue, and I don't want that I should disconnect in between. Fine. Okay. Screen is visible to you, right?
Yes, ma'am. It's visible.
Yeah. So see, what I'm going to tell you about this, the point which we are going to learn today, that is a relationship, quantitative relationship of mass and volume of reactant and product. Why we are going to use, how we are going to use mass and volume in the stoichiometry. Okay, fine. That we are going to see in a detail in this case. Earlier, we have seen about the mole-mole relationship. Then we have seen about the mass-mass relationship, and both examples we have seen. Now we're going to see about the mass and volume relationship. Shall I start?
Yes, ma'am.
Yeah. Your friend has been joined or not?
No,
Oh my
ma'am.
God, what happened? It's visible to you?
Yes, ma'am.
Okay. Only two participants, means me and you. Nobody else has joined yet. Okay. See about the mass and volume relationship, what is given to you. In this, it relates the mass of species, means either a reactant or the product, and the volume of gaseous species. Means one would be either in a solid state, okay, and another would be in a gaseous state. Means whatever reactant or product would be in a gaseous state, its volume you need to consider. And we have to see how mass is related to volume in a stoichiometric way. Fine? Yes or no? Understood? Jaswant, are you there?
Yes, ma'am. Understood.
Freedom has joined or not?
No, ma'am.
Okay, fine. No issues. Okay, see here. It relates the mass of species, either reactant or product. Okay. The relationship would be in between mass and volume, right? Mass either reactant or product, fine. Or else volume of reactant or product, correct? And this would be related to what? Gas, gaseous products or gaseous reactant, correct? Yes or no? In this way, we are going to see the mass and volume relationship. So example is given to you, that is calcium carbonate. When heated strongly, it will get decomposed, and you will get a calcium oxide and the carbon dioxide. Calcium oxide has another natural name, that is nothing but what? Quicklime, right? Yes,
Yes, ma'am.
you might have learned in your grade 1. And calcium carbonate also have one of the common name. Do you know the name of this calcium carbonate?
It's
Yeah.
later.
What is the name of calcium carbonate? Limestone, correct?
Yes, ma'am.
Yeah. Yes or no? Yeah. So when limestone is heated strongly, CaCO3 in a solid state, if you heat it, what happens? It get decomposed into calcium oxide in a solid state, and it will release a carbon dioxide. And it's a balanced equation, correct? Yes or no? Do you need to balance it? No, because here would be one calcium, here would be one carbon, and then 3 oxygen. You can see here one oxygen and here 2 oxygen. Overall, it is 3 oxygen, right? Let us take a weight of calcium carbonate as a gram. They have said the weight of this calcium carbonate, we have to take it as a gram. How are you going to take? A gram, correct? Yeah, fine. Then moles of CaCO3 would be what? How are you going to calculate the moles? Already we know mole is equal to given mass upon molecular mass, correct? Yes? Yeah. So molecular mass of CaCO3 is what? First of all, you calculate that. What it is? Calcium atomic mass is 40. So 1 into 40. 1 into 12 because carbon has atomic mass 12. And oxygen, 3 atoms of oxygen multiplied by 16 because atomic mass of oxygen is 16. What would be the calculation? I guess it would be 100, right?
Yes, ma'am.
AMU. And when you express in terms of gram, it becomes 100 gram, and you have to say it gram molar mass. And when given mass is divided by gram molecular mass or gram molar mass, you will get the number of moles. Correct? Yes or no?
Yes, ma'am.
Yeah?
Yes, ma'am.
Yeah. Pritam has joined. Yeah?
Yes, ma'am.
Are you there?
Yes,
Yeah,
ma'am.
actually, what I have done, I have kept my video off because I don't want that any connectivity issue should arise. Fine.
Yes, ma'am.
Okay. I hope up to this you understand. You might have joined just now. So I'll just
No,
brief you
I
about
understood.
what I have. Okay, fine. No issues then. Okay. So see, what else we are going to learn in this? Mole we have learned, right? How to calculate. You get a 1 mole of calcium carbonate, right? Now you have to find out 1 mole of calcium carbonate will produce how many moles of carbon dioxide? 1 mole of carbon dioxide. Here it is written, you can see. I'll show with a different pen so it will be visible to you. 1 mole of calcium carbonate gives you what? 1 mole of carbon dioxide, correct? Yes? You can see the reaction. Here 1 mole of calcium carbonate, when you heat it, it will produce only 1 mole of carbon dioxide. It will produce calcium oxide surely, but then at the same time, it will release only 1 mole of carbon dioxide. Clear?
Yes.
Yes or no?
Yes,
Yes
ma'am.
or no? Yeah. So 1 mole of calcium carbonate would be what? We have considered what? Calcium carbonate would be a gram. So the mole of calcium carbonate would be A upon 100. Because what is our formula to calculate mole? Given mass upon gram molar mass. Correct? Yes or no? Means A upon 100 moles of calcium carbonate, okay, will produce how many carbon dioxide? It will also produce the A upon 100 moles of carbon dioxide. Correct? Because 1 mole of calcium carbonate will produce 1 mole of carbon dioxide. Means A upon 100 moles of calcium carbonate will produce A upon 100 moles of carbon dioxide. Is it clear? Is it clear for both of you? Yes or no?
Yes, ma'am.
Yeah. Now, how are you going to calculate the volume? How are you going to calculate the volume? We know that whatever gaseous substance we are going to use, that can be converted into volume by knowing its mole. Because we know 1 mole of any gaseous substance would occupy how much? 22.4 liter space. Isn't it? Yes or no? Yes? Or 22,400 milliliter space. Yes or no? Already we have learned this. I gave you in a written as well. Means I asked you to write down. I don't know whether you wrote or not, but then it's very important. Fine. So volume of carbon dioxide, how are you going to calculate? Volume of carbon dioxide produced is equal to number of moles of carbon dioxide multiplied with molar volume at a STP. So what is the molar volume at STP? That is 22.4. Correct? Yes or no?
Mm.
Yeah, what it will
Yes,
be?
ma'am.
22.4. And hence you will get the calculation for number of moles of carbon dioxide produced is equal to,
A by 100.
I'll show you here. Carbon dioxide is equal to of carbon dioxide, volume of carbon dioxide would be produced, not moles. Moles already we have calculated by knowing the moles of calcium carbonate, right? So here what? Volume of carbon dioxide is equal to number of moles of carbon dioxide multiplied with, right, molar volume at STP. What is STP? Standard temperature pressure. So here that is equal to how much? Number of moles A upon 100 multiplied with what? Molar volume at STP is 22.4. Clear? So this is the volume of CO2. Means if you know the number of moles of reactant, you are able to calculate the volume of product. This is a relation in between mole and volume in a stoichiometric way. Clear? Yes?
But
Yeah. Any query about it?
no.
Do you have any query? Anything you have not understand? If it is so, please let me know. Shall I raise it?
Yes.
Yeah. So write down the next relation, volume relation. Fine. So the next is volume relationship. It is also one of the important part. Okay, fine. Just a minute. Okay, now we are going to learn about the volume relationship. Fine. So what is given here? See, it is related the volume of gaseous species, either reactant or product, with the volume of another gaseous species that is also either reactant or product involved into the chemical reaction. And for that reason, they have given you example, which we have already seen. That is when 1 mole of nitrogen molecule reacted with 3 moles of hydrogen molecule, you will get what? 2 moles of ammonia gas, NH3. Correct? Already we have seen its balance, it's a balance equation, right? And when it won't be balance equation, you just have to balance it. How to balance, you have learned into the grade 10th. And I think in the previous class, I have taught you about this. Isn't it?
Yes, ma'am.
Yes, both of you are aware how to balance the equation?
Yes, ma'am.
Yeah. Now, here what they said, let us consider the volume of N2 as a liter. Now, both volume we have to consider. We are not going to consider mass or mole, right? We are going to consider what? Volume of reactant as well as volume of product. So what they said, let us consider the volume of N2 as a liter. So N2 is what? A liter. Correct? At STP. And 1 mole of N2 produces how many moles of ammonia? By the reaction, we come to know 1 mole of
2
N2
moles.
produces how many moles of ammonia?
2 moles.
2 moles of ammonia. Yeah. And volume is nothing but what? A liter. Correct? So number of moles of N2, how you're going to calculate? You have a volume. Given volume is A. And standard volume at STP is nothing but what? We know the value 22.4. Clear? Yes or no? By that you are able to calculate the number of moles of N2, isn't it?
Yes.
You're able to calculate or not? Yes.
Yes, ma'am.
So you have to calculate it. That is for what? That is for what? 1 mole of N2. But then how many moles of NH3 would produce? By that, 2 moles of NH3. So whatever value you will get for the N2, that need to be multiplied by what? 2. Clear? When I'll write, you will get the more clarification about it. See, what we know that 1 mole of nitrogen is there. It has a liter volume, right? So mole of N2, a number of moles of N2 is equal to, how can you write? Volume of nitrogen, or given volume of nitrogen, we can say, divided by molar volume at STP. Correct? What it will be? Given volume of N2 is nothing but A, which we have assumed over here, right? Upon molar volume at STP is nothing but what? 22.4 liter. Yes?
Yes, ma'am.
Yeah? So this
Yes,
is what? Moles of N2. And 1 mole of N2 would produce what? What we know, 1 mole of N2 is produced 2 moles of NH3. So 1 mole of N2 would produce what? 2 into A upon 22.4 moles of NH3. Clear? Understood?
yes, ma'am.
Yes. And hence it is given over here. See, number of moles of NH3 produced is 2 into A upon 22.4. Clear? Yeah. Now we have to calculate the volume of NH3 produced, right? So volume of NH3 produced at STP is equal to number of moles of NH3 multiplied by molar volume at STP. That is nothing but what? 22.4. We have to multiply it. Shall I erase the whatever reaction I have written earlier? Shall I erase it?
Yes, ma'am.
I hope you might have written it.
Yes,
Hopefully,
ma'am.
fine. Okay. So these are the calculation for what? 2 terms. First term is what? Your N2, and this is for what? NH3. 2 moles of NH3. Clear? Now see, number of moles of NH3 produced is 2 into A upon 22.4. Up to this you have understand. Now you're going to calculate the volume of NH3. Now you can see volume, how we are going to calculate. Whatever volume is given, that need to be multiplied with what? Molar volume. Correct? Number of moles when multiplied by the molar volume, you will get the proper volume of NH3. Or generally, if you have to calculate the number of moles, I'll let you know how you have to do. Number of moles I have to calculate, suppose. Number of moles of NH3. How I'm going to calculate here? Volume of NH3 upon molar volume at STP, correct? Yes, this is the formula, basic formula, which we have utilized here as well for the nitrogen, correct?
Yes, ma'am.
Yeah, basic formula. Now what you're going to do here, you just have to rotate the terms. We have to calculate the volume of NH3. This molar volume at STP is divided over here. It moves that side, it become multiplied. Yes? Yes?
Yeah.
So what you will get? What you will get? Volume of NH3 is equal to volume of NH3 is equal to number of moles of NH3 multiplied by molar volume at STP. Clear? So number of moles of NH3 is nothing but this 2 into A upon 22.4 multiplied by molar volume at STP, that is 22.4. 22.4 get cancelled. So volume is equal to what? 2 into A, 2 A liter. Correct?
Yes, ma'am.
Yes?
Yes, ma'am.
Understood everybody, both of you? Yeah. Easy? Yeah. Is it easy? Other one,
Yes,
what
ma'am.
is name? Just one. Are you understanding?
Yes, ma'am.
Fine. I'll erase it now. We are going to learn about the limiting reagent. Shall I erase it? Fine. See, now we are going to learn about the new term that is limiting reagent, and number of questions would ask on it. Fine. You should be aware what it is exactly. So about limiting reagent is what? When more than one reagent or the reactant react to give a various products, then the number of moles of product of the amount of various product forms according to the reagent or the reactant which is completely consumed during the reaction. The reagent or the reactant which is completely consumed during the reaction is called as limiting reagent. This is one of the important sentence. If you want to write down in your notebook, you can. It's very, very important. I'm going to highlight it over here. See,
Can you just give us the
the
important things?
reagent or the reactant which is completely consumed during the reaction is called limiting reagent. Means sometimes what happen whenever you write a chemical reaction or whenever you do any chemical reaction, there would be two or more reactants would be present in that reaction. Sometimes only one, but then most of the time two or more than two. But among those two, only one would be consumed completely in the reaction. And the one which is consumed completely in the chemical reaction is called as limiting reagent. Okay, understood? Yeah. The reagent which gives the least number of moles of a product is called limiting reagent. Understand what has been said? See, the reagent which is gives the least number of moles of the product is called limiting reagent. Means the reactant which forms a less number of moles of the product is called as limiting reagent. And another reagent would be excess reagent. Okay, means two reactant would be there. Among that, one is limiting, then other one would be excess. Clear?
Yes, ma'am.
Yes. When the amount of more than one reactant are given, then the stoichiometric calculation must be based on limiting reagent. Means if in your chemical reaction, more than one reactant is given, that time your stoichiometric calculation must be on the basis of limiting reagent. If you use your excess reagent, your calculation would be wrong. Understand? Which reagent you have to use? Limiting reagent. Now, very big question arises might be in front of you, like how to find out which reagent is a limiting reagent, correct? Yes or no? And to understand that in a better way, one example is given to you. See this. Process of finding limiting reagent. How to find the limiting reagent. Fine. So write down this problem. 0.5 moles of BaCl2, barium chloride, is mixed with 0.2 moles of sodium phosphate. Find the limiting reagent. So a problem, I will write it here in a big letter if you're not, it's not visible to you, right? 0.5 moles of BaCl2 is mixed with 0.2 moles of Na3PO, right? Find the limiting reagent. Okay. To find limiting reagent, basically you should write the balance equation, right? So what is happening in here in this reaction? 0.5 moles of barium chloride, BaCl2, mixed with what? 0.2 moles of sodium phosphate, like Na3PO4. Correct? Yes or no? So what it will form? This will be what? Which reaction? Come on, tell me, type of chemical reaction. Mutually exchange of ions will happen in this or not?
Double displacement.
Just one. Huh? Double displacement, is it?
Yes, ma'am.
Yeah. Why? Because mutual exchanges happen. Barium will go with the phosphate and sodium will come with the chlorine. So basically, we know that when sodium and chlorine combine, they will form the salt, NaCl, and the remaining is here barium and the phosphate. What would be the formula for that? This is answer is here beside you, but then this you don't have to consider. You have to write balance equation by yourself. You should know the valency of barium. Barium is +2. Phosphate is -3. Correct?
Yes,
Is it?
ma'am.
Go for cross multiplication and let me know the compound which will be formed, Ba3. Right? PO3 is a polyatomic, so it will be in a bracket. PO4, sorry, PO4 multiplied by 2. So this
2.
is your one of the product. Yeah,
Yes, ma'am.
Ba3, PO4 twice. Clear? Is it balance? Is this reaction balance? No, you have to balance it, correct? How are you
Yes,
going to do
ma'am.
that?
By
How are you going to
balance.
do that? You can check three barium is here. Here only one barium. To balance, we have to multiply it by 3. When you multiply it by 3, your chlorine become 3 2s are 6. And your chlorine is only 1. So balance it, you need to multiply it by 6. Isn't it? If you multiply it by 6, your sodium becomes 6 and here sodium is only 3. So to make it 6, you have to multiply it by 2.
2.
2. 2 3s are 6, beta.
Yes, ma'am.
Correct? Yeah. So this is your balance equation now. Yes, it's your balance equation. Now, how to find the limiting reagent? And to find it out, you have to assume among these two, means barium chloride and the sodium phosphate, one of the reagent is a limiting reagent. Like this, you have to assume. Fine. So what we are going to do? We are going to consider a barium chloride as a limiting reagent. What we are going to consider? Barium chloride as a limiting reagent. Fine. Fine. So what they said, 3 moles of barium chloride. You can see how many moles are there in the barium chloride? 3 moles of barium chloride when react with 2 moles of sodium phosphate, it will form barium phosphate and the 6 moles of sodium chloride. Correct? This is a reaction.
Yes.
Yeah. Now, as per the reaction, 3 moles of barium chloride, BaCl2, will react with what requires how many? 2 moles of sodium phosphate, Na2PO4, Na3PO4, I'm sorry.
Na3. 3, ma'am.
Correct?
Yes.
Yes, Na3PO4. It's the sodium phosphate. So, clear? Yes or no?
Yes, ma'am. Yes, ma'am.
Yeah. Okay, so you should be revert me. Actually, I'm not understanding whether you're gaining things or not. So your response is really very important. Okay, see here. 0.5 moles of barium chloride is given to us. Right? 3 moles require 2 moles of Na2PO4. Then 0.5 moles of barium chloride, BaCl2, require how many?
0.33.
X we would consider. Then go for the cross multiplication. What you'll get? X into 3 is equal to 2 into 0.5. And X is equal to what then? 2 into 0.5 upon 3. Correct? Yes?
Yes.
Yes or no? How much it
Yes,
will be
ma'am.
now? Come on, tell me how much it will be now. 2 by 3 is
0.
equal to, or else
0.33.
um,
1 by 3.
I can write in this manner also, simplify it. 2 by 3 as it is. Okay, and 0.5 is nothing but 1/2. Clear?
Yes.
Yes,
It's 1 by 3,
0.5 means what? 1/2. Yeah, it will be what? 2 by 6 means 1 by 3. And 1 by 3, if you means like find the ratio, you will get the answer. That would be what? 0.33. Correct?
Yes,
I'll
ma'am.
show you. If you want to go for the direct calculation, that's fine. But then I try to simplify it. It's up to you which method you have to follow. So here what? 2 ones are 2 and 3 twos are 6. That is 2 ones are 2, 2 threes are 6, 1 by 3. And if you divide this term, you will get 0.33 answer. This is what? This is what? Na3PO4 means 0.5 moles of BaCl2 requires how many? 0.33
0.33 moles of Na3PO.
sodium phosphate. Yes, right? But in your problem, what they gave you? 0.5 moles of barium chloride is mixed with what? 0.2 moles of sodium phosphate. Correct? Yes or no?
Yes, ma'am.
Yeah? So by that, what you come to know? This value 0.33 is greater than 0.2, which is
Yes,
more
ma'am.
than that of your sodium phosphate value. And as it is excess, what we can say, your barium chloride would not be a limiting reagent, means your assumption is wrong. Instead, your sodium phosphate, it acts as a limiting reagent, LR, and your barium chloride would be excess reagent. Understood?
Yes,
Right?
ma'am.
How to find out understood or not?
Yes,
So you just
ma'am.
have to calculate the basis of your given problem. Okay, compare the values. If your value is greater than that of the given value, so that won't be a limiting reagent. Either it is equal or less than the given value, then it is limiting reagent. If you write down somewhere, that's fine, no issues. See, if barium chloride is a limiting reagent, then it requires 0.33 moles of sodium phosphate, which is more than the given quantity, that is nothing but 0.2 moles, right? Of sodium phosphate, and therefore barium chloride is not going to react completely with sodium phosphate. Hence, barium chloride is not a limiting reagent and sodium phosphate is a limiting reagent. Then what does that barium chloride called? It is known as a excess agent or excess reagent. Okay, understood?
Yes, ma'am.
Hello.
Yes, ma'am.
Okay,
Yes,
clear?
ma'am.
We'll move forward then. See what is given. A note of good practice, how to practice it in good manner. In order to find the limiting reagent among the reactants given, it is convenient to convert the amount of the reactant into their moles. What you have to do, you have to convert it into moles. This is one of the what we can say important trick. Please note it down somewhere in your notebook. First of all, you have to convert it into moles. Reactant, whatever reactants are given, that you need to convert into moles. Fine. Now, calculation involving practical yields, that we will see what it is exactly. Your chapter is about to end today. Maybe it will end. It won't be end. Actually, one theory part has remained that I'll take it by tomorrow. So tomorrow it may end. Laws are there, several laws that I'll explain once.
Yes, ma'am.
Yeah, fine. See, calculation involving percentage yield or percent yield, how to calculate. In a general, when a reaction is carried out in the laboratory, we do not obtain actually the theoretical amount of the product. The amount of the product that is actually obtained is called the actual yield. Knowing the actual yield and theoretical yield, the percentage yield can be calculated. Means when you work into the laboratory with chemicals, that time whatever yield you will get and what you weigh on the weighing balance, that would be your actual yield. What it will be?
Actual yield.
Actual yield. Right. And by the basis of calculation, when you calculate on a paper, that will be your theoretical yield. Right? And if you know your theoretical yield and practical yield and theoretical yield, you are able to calculate the percentage yield. How are you going to do that? Percentage yield is equal to actual yield upon, there's a spelling error that I guess. That will be YIE. Okay? Please keep it in your mind.
Yes, ma'am.
YIE.
Ma'am, will there
Actual
be
yield
class
upon
tomorrow?
theoretical yield.
Ma'am,
Sorry.
will there be class tomorrow?
I'll get it confirmed. If sir allows me, then I will conduct class tomorrow. Okay. If sir allow me, because I told you, a few lapses have happened because of the network, and I will cover the content. If he allow me, I'll have a word with sir. Definitely, I'll conduct the class. Fine.
Yes, ma'am.
But then if there won't be class, I'll post like that message in the group as well. So you'll be aware of it. Fine. And as it is percentage, this ratio you have to multiply with 100. Correct?
Okay, ma'am.
Yeah?
Yes, ma'am.
Fine. So these are the few questions. If you try to solve, that's really good. The circle one you have to try at least. If you want to note down this question, please note down, or else you can take a screenshot as well. It's completely up to you what exactly you want. And options are given to you. These are the assessment questions for you. Try to solve because it's completely depending upon our chapter. If you face any difficulty, kindly post it into the group so I can sort your problems. But then at least try to solve by yourself. That's very important. Okay.
Yes, ma'am.
Any other query, anything is there in your mind, then please let me know. And few
No,
more
ma'am.
subjective are there below. That too, you take a screenshot and try to solve it by yourself. Wherever you face difficulty, please let me know, because I'm not going to post questions today. If possible, definitely I'll post few questions by tomorrow, because my resources are not with me currently. Then yes, I'll get it by today, and tomorrow I'll post for you. Okay?
Yes, ma'am.
Fine. If any difficulty, any query while solving these problems, without any hesitation, please ask. I'll explain you thoroughly. Fine. So in the next period, whenever we have, either tomorrow or maybe on Monday, I'm going to discuss with you about the law of conservation of mass, law of constant proportion, then the Gauss's law, and the law of multiple proportion. Number 3 to 4 laws are there that we are going to see, and we are going to see the examples of those laws. Okay, fine.
Yes, ma'am.
So that thing is subjective thing. If you get any content regarding, please go through it, read it, so you will understand the concept in a better manner. Fine. And once that content would be done, your chapter would finish. So about that, only questions I will post on regular basis, so you can practice it.
Yes,
Fine.
ma'am.
Fine. Other like subjects chapter is over or not? Any one chapter is over?
Yeah, ma'am.
Sorry?
Physics.
Physics over.
Yeah.
Okay. And rest all like sets are still going on, right?
Yeah.
Sets, mathematics. Fine. No issues. Okay. Everything clear to you?
Yes, ma'am.
Yeah. Shall I end the class now?
Okay.
So bye-bye. Take care. We'll meet again either by tomorrow